And I got here around noon or so. It was about 5 miles from my house. All right, I'm not alone. Okay, good. So I am. So back in 1978 or 79, programming my first programming classes, argued with my classmates that we'll never get sound, audio on a computer because the bandwidth and the density, in a floppy disk just can't be done, right? Obviously, we were wrong. So I can talk to you about really what SolarWinds, the company I'm at, it's a network monitoring company. Our software is used by IT guys, primarily network operations people, to keep their networks up and running, IP networks. Primarily performance, operations, uptime, and availability. And so from listening to the challenges and problems I've been hearing here the last just 2 or 3 hours, there's actually a couple of analogies here. One is adopting VoIP. So the transition from plain old telephone service, the old reliable Verizon, Bell Atlantic, whatever, to VoIP it's pretty well done now. It was really interesting for a while, but it's going to be, I think it's the exact same problem as video. You have to deal with packets flowing through the network. You have latency, jitter, packet loss. And then, voice, it's MOS score. I'm sure there's a video equivalent to a MOS score. For the perceived quality of video when you have jitter, latency, packet loss. Maybe there's some other metric in there, but I imagine it's probably the exact same thing. I think the lessons learned in how we're dealing with ensuring VoIPs, I can share that and see where it's going. So as technology goes faster, the computers get faster, networks get faster, the class of problems we can take on with computer networks, video, is just a matter of time. And doing it with standard off-the-shelf $50 pieces of equipment is, well, I probably shouldn't say that. But my level of video expertise, I wowed my church members when I stood up video Skype with a $60 webcam, and they think I'm brilliant, right? That's my expertise in video. But the network, it does work well in our church. I do have that working okay, the wireless. Let's talk about the challenges in network performance, automated tools for doing network monitoring. It's really commercial stuff. Commercial off the shelf, what's done today, best practices, what tools are available, and especially how they're applicable to, I think, your needs and uses. Talk about the keys to establishing availability and visibility into what's going on in the network from different aspects. And then talk about a concept called NetFlow, or technology called NetFlow, is who's using what bandwidth. And then a few other items. Okay, so the challenge is, hey, there's more data, right? As if we didn't know that. So I guess we all know there's more data going out there, and the availability of bandwidth, of course, can be a challenge because the number of users at any time can use bandwidth. So I'm assuming here, first of all, which may be a bad assumption, is that it's a shared network, right? So in a corporate network today, my company's network, voice and data are on the same network. And our Herndon field office, we're having problems with voice. They're rebooting the router at noon today, well, 12:30, a couple hours ago. I think they didn't set up the quality of service properly, so the voice calls were terrible during business hours, and hopefully that's fixed by now, right? It's a new field office we stood up in January. So if you have shared networks, video and something else, there are ways to fix that. And the ways to do that were designed into the IP protocol by DARPA, back in the 70s when it was first invented. It was quality of service and doing preemptive for packets. So the challenges in there, different network traffic can get in and consume things, and then changes in bandwidth. So my son actually uses my software. He's a customer of mine, and he works for local county government, Prince George's County, operating their campus, wide network. So he says during March Madness, he's monitoring the network. He knows what's going on. The bandwidth goes up, of course, And so people say, we need more bandwidth. And it says, well, I can't give you more bandwidth. Well, I could, but I'm not going to, because if I do, there's this, I guess, adaptive video codec or something. It says, oh, there's more bandwidth. The video quality just gets better and uses it all, right? So he's onto that trick. So that's just one of the problems here. So I think you're all aware of those problems. So what is network performance monitoring? It's really visibility into what the heck is going on, where is it busy, and when is it busy, and where do I need to make improvements? Where are the hot spots, right? Not a Wi-Fi hotspot, but where is a bottleneck, right? And then how can you fix it? So using network performance, doing network performance monitoring is a great way to do that. Yeah, you can do ping and trace route. That gives you basic connectivity, but it does not really give you performance. Trace route gives you some latency metrics for ICMP ping, but it's not really a performance metric. You need better data than that. And so this is just a screenshot of our price. So just so you know, so SolarWinds, we're a publicly traded company, $500 million in revenue now, growing about 25% a year. We are known as the low-cost commodity network monitoring software provider. We're a pure software company. The IT guys, you ever heard of SolarWinds, anybody? Oh, wow, you have a whole SolarWinds, okay. SolarWinds, a network monitoring company. Wow, okay, so even though you're not network, okay. So, so this is just a screenshot. So here you can see the, I think it's, yeah, here's this lab cluster, that machine and that WAN connection, 94% busy receive, 94% transmit, right? This top 10 screen is like the most popular, right? The 10 busiest this, the 10 busiest that, the 10 worst this, the 10 worst that, wireless clients and so on. So just, we collect the data, we put it together, and really the value in our case is we've been pretty good over the last few years to talk to customers, understand what they need, and build the user interface. And the data is all accessible to anybody. It's just anyway, we've gotten good at presenting in a good way. So here's another example, just some performance monitoring screenshots. This is a map and the link utilization. It's showing red, 85% utilized in those areas, and that updates every few minutes when it talks to it. So just better visibility, what's going on, what's the status, where are my problems. There's capacity forecasting. We've added, when is this link going to be at capacity? Is it now? When's it going to be warning? Is it going to be 6 months from now? Just simple straight line extrapolation, tracking over time. So just basic visibility, what's going on with network links and utilization. Now, there's another technology, I'm not sure with this. Anybody heard of NetFlow, JFlow, SFlow, RFlow? A couple of you, okay. So you're gonna learn something here. So routers have a feature, like Cisco routers, iOS, has a feature called NetFlow. Juniper, they call it JFlow, RFlow, SFlow, the other vendors' versions of it. Basically, you can go into a router that forwards IP packets and give it a command to say, hey, router, start keeping score. Keep score whenever you route a conversation. A conversation is this IP address and this IP address are exchanging packets using these ports. It's a conversation. This browser going to this website, that's a conversation. This email client going to this email server, that's a conversation. It starts at some point, it goes on for a while, they exchange this much data. Routers, modern routers, can be told to keep score, as Cisco calls it, enable flow accounting, and then it's told keep score of the conversations and periodically send some UDP packets to some IP address, in this case a SolarWinds server running a NetFlow collector, and there are many NetFlow collector tools out there. Ours is just one of them. It's very much, there are free tools that accept NetFlow and do this, right? The whole question is which ones scale the best and have the best UI and so on. So by getting this NetFlow data, what you learn is what conversations are going on. So the idea is with network performance monitoring, it's like which links are busy. Hey, it's my WAN link, right? Or when your use case video, it's who knows what's going to be. An internal link, we have a bottleneck with lots of video streaming in your studios if you ever get to that point, it sounds like. But this will tell you, for that interface that has flow accounting enabled, you now have visibility into what conversations are using that bandwidth. What are the top talkers? What IP addresses are consuming the most bandwidth during this period of time? And how much is it? How many packets? How many bytes? How many bits? And who's using it? And both sides of the conversation is always two IP addresses exchanging data, and whether it's unicast or multicast even. It should be multicast. So that tells you who's using what, and by reducing the mean time to innocence, it's like who is using it, right? So with this, if you're doing shared bandwidth, you can always educate your end users. No, you shouldn't be watching YouTube videos 16 hours a day or 10 hours a day at work. You should be doing something else. March Madness, everybody shouldn't be watching it at the same time because it slows down email. And of course, you can monitor it, alert on it. So here's some screenshots of NetFlow. I don't know if you can see it, but just our screen. So the top applications, So this top application that you can't read is syslog. And then there's Microsoft SQL Server, Oracle SQL, SNMP. It could very well be whatever video. It's basically what IP address and ports, right? So I guess when you stream video, you're probably doing UDP to some port, I guess, if it's IP. So it'll be very easy to define an application, which is, if it's this IP address and this port, that means this. And you can give it whatever name you want, and it'll show up in here and be tracked as an application. The top 5 conversations are between F. Mendez and Hulu.com. It's basically, these are the 2 computers and the associated IP addresses. This is the top conversation in the last hour, is between this F. Mendez machine and Hulu.com. Here's how much data, ingress and egress packets. What is the percent utilization of the interface from that conversation? So that's standard routers that are there today. Your network guys would need to enable flow accounting or whatever, Juniper or whatever, they have that, and you need some kind of a NetFlow collector software. There's free version, like I said. SolarWinds has a paid version that has a nice UI and a little more management. All right, so is it the application or the network? I'm not sure how this would apply here for your broadcasting, but I think it's worth talking about. So packet analysis, of course, you can use Wireshark, capture the packet to dig into it, and if you're really clever with that and know what you're doing, you can learn something. I'm not that experienced with Wireshark. I can stumble through it maybe and figure something out, but there is a way to look at applications, and actually this is a feature we added recently that I think would help here, is we added this ability to do a software probe. So you can have a Windows machine, a VM, or a physical machine, configure it to act as a probe. So you do spanner mirroring, so it'll see the packets on another interface on that machine. And all we're doing so far is we're looking at the application protocols. We do packet inspection. We license a library of several hundred applications. And we're measuring 2 things. The TCP handshake, the SYN-ACK handshake, it's a proxy for network latency. So if you have high network latency, when, let's say, a browser goes to a web server, right? That's an application, this web app, HTTP application. The TCP handshake will be the first thing the browser does, sets up a socket connection, actually 4 socket connections typically for a browser. But when it sets it up, it has to do this TCP SYN-ACK, and there's time, and that's basically a measure of network latency. But then we also measure time to first byte, and the time to first byte is now, once the socket's set up, at some point the browser sends a request, HTTP GET, to the server, wait, and then we see the response coming back from the server, right? That's a think time for the server. It has to go do something and then come back with it. And so we're measuring, for all those applications, the network latency, or network response time, and the application response time is the application of the network. So again, I'm not quite sure if you're just flowing data through how this applies, unless the application is kind of pulling, requesting. I'm really not sure if that's really going to be in there or not. But it can be done. It's done in real time, and for the, should I say, the industry standard applications. I really don't know what there are for video there, but I can break it down. Is it network latency or the application, either server or the database, something behind the application that's causing performance issues? And so here's just a couple of screenshots. So here's the top 10 network response times, which is the TCP handshake. FTP in this case, 3 seconds is the network response time, and it went up at this point in time. So something happened to the network between the FTP clients and FTP server that we're seeing during that time period, where it clearly got affected. And then here's the application response time. In this case, it's Microsoft SQL Server, 4 seconds, and it's been a constant 4-second waiting for the application to respond. The network latency, for SQL over here is, quarter of a second, but 4 seconds for the application to respond. So that's just kind of the latest thing, SolarWinds trick that we can do. All right, quality of service. I heard some discussion of QoS. So for IP, QoS or the DSCP bits, differentiated service code points, were included by DARPA when the geniuses built the IP protocol. And the use case was, remember, IP was built for DoD, for resilient networks that are survivable, and preemptive messaging. Commanders call for fire, that phone call and that message better go through, as opposed to Sergeant Snuffy calling the mess hall, what's for lunch, right? And so that's built into the IP protocol since day one. It's always been there, but it's, and it was used really with VoIP the first time it started being, well, as far as I know, widely being used, because without quality of service, your VoIP calls can be terrible if you don't set it up right. So basically, you want to implement quality of service. I'm not quite sure how you do that with net neutrality on the internet, but if it's your private network, you do what you want. But you really, to get good low latency or whatever you need, live video, live audio, you got to have low latency and low jitter and low packet loss. So you can set QoS policies. I'm not sure if all routers do, but some routers do. So by default, most don't do anything with QoS. The biggest example I know of that sets quality of service is actually our biggest customers, the U.S. Army. The tactical units, when they're deployed, they get their guns and stuff, and they get their network gear, their Cisco, their satellite terminals, and SolarWinds software to monitor it. And when they're tactical units, sometimes they have 64K bit links, right? They drive around and shoot things, and they're not always plugged in. They don't always have a good link. And so they have to make do with that. So without QoS, and everything's IP. VoIP phones for like 12, 15 years now. That's all they do out tactical in the Army. So those phone calls have to go through, email on the same link, 64K bit link. Without QoS, the phone calls wouldn't work. They'd always be behind someone's email or web page download. So the QoS has been implemented. They implement them in different places on the network, especially before the congested links. So that QoS capability is there as part of IP, and that's probably something that you have to do to make sure things get through. So if you're gonna have any kind of shared network, if you make it totally private, and this does nothing but video, like the SDN discussion here, where you have this private network, it's not shared, then you can control, exactly what's on it. But if it's gonna be messier and you're gonna just use a shared network, which I think, we got 10 gigabit links now, so 5 years we got 100 gigabit links, suddenly, it's a lot less of an issue, but still, you have to make sure the right stuff gets through. So by implementing the QoS capabilities, quality of service, you can make sure your stuff gets through, or the important stuff gets through in a timely manner, and the other stuff, not so important, gets dropped. So built into one of our tools, it's actually our NetFlow traffic analyzer product, actually has this quality of service monitoring with it. In this case, if you're using Cisco's class-based quality of service, the Cisco CBQoS on Cisco routers, then we can talk to the CBQoS MIB using SNMP, and we get the pre-policy class map, which is here's the traffic before the QoS policy kicked in, the post-policy, and there's also a drop, so it would be the difference between them. And it showed the classes of service, levels of service, what's being dropped when, so you know exactly when the router, when it's dropping and what's going on and why it's being dropped, because you'll see the traffic mix. So if nothing else, if you're doing shared and you do have to drop packets somewhere, you'll know when it's happening, you know what's being dropped, so you can at least be aware of what's going on and not be blind, running trace route and ping and trying to guess what's going on. It's nice to actually have some facts to help with troubleshooting. Another one, guest wireless network. So this is more of a commercial IT thing, but and partially a security thing is, we have our corporate office. We got our corporate network, corporate wireless for your, company provided devices. But we have a guest wireless network, and everyone puts their phones on our guest Wi-Fi, right? That's probably where it should be, because it's less secure. It doesn't have access to our corporate systems and so on, and it keeps that bandwidth off your regular networks. So I guess that's just kind of a separating the networks in some way between them. Yeah, so this is just a comment if you're doing shared networks for video, voice, so in our case, voice and everything else. If we don't have QoS, you really got to talk to people about, I remember, 15 years ago, our field office line, our T1 line, with 30 people in the office, it would be terrible. And then we found out that the administrator in the office, she liked to listen to streaming radio all day long on her computer. And that was using half the bandwidth of the T1 line. And so let's just buy her a radio for $50. And, it was so much better. But we didn't know then, she didn't know, and we weren't doing QoS, right? This is a long time ago. And had all kinds of problems. So you still need to be aware of that. But if you have NetFlow, for example, then you know what's going on, and you can talk to people, right? Humiliate them if you want to, if that's what you enjoy, or talk to them nicely, but at least you have factual information. You can educate people so they can avoid doing stupid things. Well, not stupid, it's just things that they don't know about and have other bad consequences. And then, make sure management knows that there are problems and can be problems, and this is the cause of them, and here's how you can fix them. Like, you can buy more bandwidth, or you can implement a QoS strategy, or buy radios for sound. So just some screenshots here of detailed performance monitoring with our software. There's kind of a new UI thing. We put an interface downtime, just a color-coded timeline, and it changes color based on how available that interface is over time. And as you zoom in, it actually gives you more detail. It's pretty cool. Our user interface people are pretty clever. Top 10 flapping routes, things that are important for corporate IT, any kind of IT system. And so the idea, holistic performance monitoring, just all kinds of data is available here. We just added a Wi-Fi feature. You actually do Wi-Fi mapping. So if you got, wireless in your office building, you can actually specify where those are. Actually, we do first is you get a drawing of your office, put it in the background, calibrate it, say this wall to this wall is 47 inches or whatever. So now it knows the dimensions, and then you say, and these are the 4 wireless access points we're monitoring, and here's their location. And actually, they can determine their own locations because they can triangulate from each other, and they'll compute the hotspots. They'll compute their coverage and their overlap, and it's pretty cool for wireless coverage. It's a brand new feature. All kinds of great stuff here. So anyway, in summary, IP network for video is possible. I'm doing it at church with a Comcast uploading video Skype. Works fine. Of course, the people that use it the most are 75, 80 years old, and they like to prefer to just dial up with their phone and put it on speakerphone. That's as high tech as most of them get. They can use a lot, but there are tools to do that, and just regular network monitoring tools. And the NetFlow part, or RFlow, SFlow, JFlow, the flow monitoring, again, will tell you who's using the bandwidth, what applications, what people, what computers. And if you implement QoS, you can make sure the important stuff gets through at the expense of some other things that are not as important. And I think that's it. Any questions?